Okay, guys, here's a little addendum, a little addition that we're going to add to our multiple angles just in the way that we answer it. I told you before when we started this section, we were going to have all of our answers just over the interval of 0. We wrote down 0 of 0 to 2 pi. So we talked about just like one trip around the unit circle. When we talk about multiple angles, I mean, obviously multiple means many. So we're going to not just narrow it down to just one trip around the unit circle. We're going to talk about an infinite amount of trips around the unit circle. So what you need to remember and what we're going to talk about and what we're going to put at the end of our answers is either plus 2 pi k, 2k pi, however you want to say it, or plus pi k. Now, what I mean by this, if you have cosine or sine, cosine, whatever, at the end of your answer, and I'll show you what I mean in a second, you're going to put plus 2k pi. And what that means is k could be the numbers of times you go around the unit circle. So say I went around 6 times, you put a 6 there. Say you went around 12 times, you put a 12 there. We're not going to do that part, but you are going to account for that multiple times around the unit circle. Like if I go here one time and I go here again, that's 2 full circles, so it would be talking about 720 degrees or 4 pi. But you end up being at the same spot. So with sine and cosine, you're going to put 2 plus 2k pi. And with tangent, it's just plus k pi. We talk about just half. So we're going to solve this the same way. I look here and I see that, okay, sine 4x is all by itself. There's nothing else here that we can look at. Nothing else we can separate. That 4 is stuck in between the sine and the x. So sine is our y value. So we're going to go over to our unit circle and we're going to find where the y values are positive 1. And it happens right here at pi over 2. So we would say right here that 4x equals pi over 2. Now, since this is sine or cosine, we're going to add the plus 2k pi behind it. Now, all that's doing is just accounting for, we can go one trip around the unit circle, we can go 12 trips around the unit circle, whatever. Now we're going to solve the same way that we did the other day. We're going to divide everything by 4. And when we do that, we get x equals, I have pi over 2 divided by 4, which is the same as pi over 2 times 1/4, which gives me pi over 8. So I have pi over 8 plus 2 goes into 2 one time, 2 goes into 4 twice. So you have k pi over 2. And that's it. All you're doing is adding this extra little piece at the end and then go through the motions of dividing when you get to the answer. So now tangent, all right? Tangent, when I think tangent, I'm going to put plus k pi at the end. So I'm going to go on the unit circle because what this is saying is where on the unit circle is my tangent positive 1. Remember what tangent is? Tangent is y over x. So where on the unit circle would my tangent be positive 1? It would be at pi over 4, and it would be at 5 pi over 4. So I'm going to say x over 3 equals pi over 4, and then I'm going to put that plus k pi, and then it's at 5 pi over 4. So x over 3 equals 5 plus k pi. And now we go through the motions. Remember, guys, this is 1/3. So what's the opposite of timesing by 1/3 or dividing by 3? You're going to multiply, right, by the reciprocal. I'm just going to multiply everything by 3. So when I do that, the 3 goes here, here, and here. So I would say, okay, these 3 cancels out. I have x equals 3 pi 4 plus 3k pi. That's it. Same thing here. Multiply everything by 3. Boom, boom, boom. So these 3's will cancel out. X equals 3 times 5 is 15 pi over 4 plus 3k pi. And that's it. So move on down here. All right, I see we're going to have to do a couple more steps, but nothing major. I see that my cosine of 3x, that's what I'm trying to isolate, trying to get all by itself. So I'm going to first add 1 to both sides. So I have 2 times cosine of 3x equals 1. And since we're doing cosine, guys, that's going to be 2k pi at the end. Now I'm going to divide everything by 2. So I have cosine 3x equals 1/2. Well, remind yourself, cosine is x value. So I'm going to the unit circle. I'm going to say, where are my x values? 1/2, positive 1/2. So x being positive 1/2 would be pi over 3 and 5 pi over 3. So we have 3x equals pi over 3 plus 2k pi. And 3x equals 5 pi over 3 plus 2k pi. Then again, we want x all by itself. So just divide everything by 3. So I have x equals, well, pi over 3 times, instead of 3 over 1, it's 1/3. I have pi over 9 plus 2k pi over 3. And then here, if we divide everything by 3, we have x equals, this would be 5 pi over 3 times 1/3, so it would be 5 pi over 9 plus 2k pi over 3. And then lastly, I have tangent, okay? So again, we want to isolate our tangent. That x over 2, it's really 1/2 times x, is stuck with tangent, so I have to isolate it. I got to get it all by itself. So I'm going to first subtract 3 from both sides. So I have 3 times the tangent of, I'm going to say 1/2 x, if you guys want to look at it that way, equals -3. Then we're going to divide both sides by 3. So I have the tangent of 1/2 x equals -1. So reminder, tangent is y over x. So where on my unit circle would my tangent be -1? That would be at 3 pi over 4 and at 7 pi over 4. So we have 1/2 x equals 3 pi over 4. And since this is tangent, it's plus k pi. Then I have 1/2 x equals 7 pi over 4 plus our k pi. Now, instead of my 1/2 in front, the opposite of multiplying by 1/2, or dividing, however you want to say it, we're going to multiply everything by 2. Easiest way to look at it. So distribute, 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 and I get x equals 2 times 3 is 6, and then 6 over 4 could reduce to and be 3 pi over 2 plus 2k pi. Then distribute, distribute, distribute. I get x equals, well, 2 times 7 would be 14. 14 over 4 would reduce to 7 pi over 2. And then it would be plus 2k pi. So, whenever you're starting off and you have multiple angles, you know it's multiple angles when there's a number in front of your x or your theta or whatever. You have to account for numerous trips around the unit circle. So if you're starting off with sine or cosine, you start off by adding 2k pi at the end of your answer. If it's tangent, then it's just k pi. Then you solve like normal, and you just make sure to either multiply or divide by whatever, by your angle measure, and also the k pi or 2k pi at the end.